Hello, good morning from California. This is Dr. Satish Singhal, PhD, Professor of Computer Science at Community College, Torrance, California. In this video, I'm just going to give a general introduction to struct in C language. I think I've done the C++ already. These days I'm teaching C, so I'm doing struct in C. First of all, some acknowledgements. Some of the slides here I'm using were created by Dr. Nell Dale of University of Texas, Austin. So thanks to Dr. Nell Dale of University of Texas, Austin, who originally provided these slides to the adopter of her C++ textbook. And I taught from her textbooks for years ago, many years ago. And so thanks to her, and no monetization is being done with these videos. So I'm not personally benefiting from using these slides. But if anybody has any copyright issues, I will put down my email. So email will be this single@lcommuno.edu, and they can write to me and I will take the copyrighted material out. These ones have been modified for C programming because they were originally in C++. Thanks, Dr. Neil. So, what are structural records? We want to talk about meaning of structured data type. We want to talk about declaring and using struct data type. A little bit later, maybe not in this video, we want to talk about C union data type. Okay, in C language, this is the summary of all the data types. We have simple ones, which have atomic value, like integral, which could be char, short, int, or long, enumerations. And then floating point type, which is float, double, long double. We have address type, which is pointer. But structured are three types: array, struct, and union. Array you have seen already. I have taught that before. We declare array with a certain length parameter, and whatever the capacity, that many members are created contiguously. So array have members. Struct have members also, though a little bit different from array. Arrays have homogeneous members. Structs have heterogeneous members. Union can have heterogeneous members, but memory is assigned only for one variable at a time. So this is a summary of C data types. A structured data type is a type in which each value is a collection of component items. Entire collection has a single name, just like entire array has a single name. A structured data type or record, entire collection has a name, but each member can be different data type. And each component can be accessed individually once a struct variable has been declared. So let's look at the C structure types. Often we have related information of various types that we would like to store together for convenient access under same identifier. So for example, we want to keep records of animal in a zoo. So we could do it this way. Let's go back, do it one at a time. We declared a variable called this animal. This is not declaration syntax, but let's say there's an animal in the zoo called this animal. And it has a structure which has following components. It is an ID, it has a name, genus, species, country, age, and weight. All these collectively form the member name for the struct whose variable this animal is. They will also be contiguous in memory like array, but their access will be different. And this will be starting address 5000 of this animal, address in the memory. This is the variable name. And next thing is, these are the member values. These are the member names, and once we fill that up, we are going to talk about how do we fill them up later. These are the member values. We could declare another animal type, another animal, and this will have the same thing. You'll have member names, member values, starting memory address. Okay, by the way, ignore this empty space. That doesn't mean that it's a member. Okay. Now we declare the struct animal type. The syntax is this: the keyword is struct, blue is all keywords. That's the user defined, programmer defined name. Programmer can choose any name they want. And now we have the members ID, name, genus, species, country, age, and weight. These are text or string, so we define them in C as arrays. Okay. Age is age on the last birthday, in weight is weight. If I do this declaration, this itself does not allocate any memory. This is just a template or prototype for the struct animal type. But once I do this declaration inside the main function, struct animal type this animal, struct animal type another animal, and then fill the values, then we'll see the picture that we saw before. These do have location in the memory. They consume the memory, not this one. So if I do those two declarations, then another animal could look like this, and this animal may look like that after filling the data. Okay. So key thing is struct have member names and the values. Soon we'll talk about how to access members of a struct. Okay, let's review the definition or declaration again. This is the syntax. The keyword struct, name of the struct, which is user or programmer defined, and a member list. Member list is semicolon separated. Member list has data type and the member name. And don't forget there is a semicolon at the end also. Okay. And member list will be like this: data type, member name, data type, member name, and you can have as many as you want. There's no limitation in the number of members struct can have. Okay, so let's summarize that. A struct declaration names a type and name of the members of the struct. A struct declaration itself does not allocate memory for any of the variable of that type. You still need to declare your struct variable, and we're going to show that in the next slide. So in the C, keyword struct is needed before the user defined struct name, followed by the variable name. For example, below is a declaration of animal type struct, variable myAnimal. The keyword struct name, variable name. Notice 3 tokens have been used here to declare struct variable. Keyword struct first, struct name, and the variable name. We show that graphically here. 3 token declaration. There's no way to get around that 3 token use in C. First token, the keyword struct, and they have to be in that order. Programmer defines struct name, which is defined before this declaration. Programmer define variable name. And as soon as this line is done, in the RAM, memory is allocated for my animal. Okay. We're going to talk a little bit more about struct declaration. If the struct declaration precedes all functions or prototypes, then it would be visible in the rest of the file. You could place it inside the function, but then only that function can use it. So usually struct declaration is a global declaration. Okay, that makes more sense. It is possible for members of different struct type to have same identifiers. So if animal type has an identifier called name, another struct called student can also have an identifier inside it called name. Struct members don't get a monopoly on the variable name. Any other struct can also have that name. A standalone function can have that variable name also. So it's possible for members of different struct types to have the same identifier. And a non-struct variable, let's say in the main function, can have same name as the struct member. There's no mix-up or confusion about that. Time permitting will give you an example of that. Very important topic of accessing a struct member for read and write access. We use the dot notation for selection of the members. In arrays, you use the square bracket notation and a subscript 0, 1, 2, 3. Here, just a dot notation is used. The way it is used is, after struct type declaration, various members can be used in your program only when they are preceded by a struct variable name and a dot, like this. This animal dot weight will be selecting the weight member of the this animal variable. Another animal dot country will be selected the country member of animal type variable called another animal. Go back in the video to see how they were declared. Okay, what are the operations on struct members? Valid operation on struct member depend only on its type. So this animal is a int type, so I can say this animal dot age equal to 18. ID was also int type, so I can say this animal dot ID equal to 207375581. But name was not integer or float or double. It was a character array which can be used for a string. So in that case, it will be this animal dot name star copy. We'll have to use star copy, comma, giant panda. So in that name field or name member, so all of a sudden I use the word field. So member and field are the same thing. Giant panda will be stored. And if I say this animal dot age plus plus, that will be fine because this is an integer type. And if I want to print age, then I can do this operation printf %d because this animal age is int type, And if I want to store some value in there, I can do this, scanf %d address of this animal dot age. So the struct instance itself has a memory location, and then each member has its own memory location as well, and you can print them as well. Okay, there are other ways to define a struct compared to what we showed in one of the slides earlier. You can define one struct variable, or you can do type definition. These are different from what we showed earlier, but these are available also. If you just need only one variable of certain struct type, you don't even have to give a struct a name. Let's say for a student you want to declare ID, name, and score, then you can do struct, no name needed here. Members that you need, closing brace, student. Student then is no longer a data type, it's just a variable. You can do student.id to get this field, student.name to get this field, student.score to get that field. So it's no longer a data type, just one single variable. So this could be useful in situations where locally you want to create a struct and use it for some length of time in a function. Otherwise, not for creating structure and all that, it's not useful. Otherwise, you can do type definition. Here, I say type def struct, char ID 10, char name 20, int score, and then student. Now, this is actually a struct type. Okay. Advantage of this, doing this is that you don't need the token struct before declaring the variable. So you could try that in C and that would be perfectly okay. In that case, this is the user defined data type, and to use this you don't need the word struct in the front. Okay, that's the advantage of this. You just need 2 tokens rather than 3 token method that I showed earlier. Okay, we are summarizing 3 variables, 3 declaration types. Just the word struct, left curly brace, right curly brace, member list, and just one name here. You could have any name. It will not be a data type. It will be just created one variable of containing these members. Or you could have a struct name, and you can create one variable right here if you want. But if later on you want to create more, you'll have to use the word struct and the name of the struct and the variable name. But you can use type define, type def struct, member list, type ID. That becomes the struct name. In that case, you don't have to use the word struct the way you used here. You can just do type underscore ID, and this will be the struct variable type. Okay, so this is the struct single variable. This is the tagged struct. You're going to need the struct every time. Or you can do the type defined, where you don't need the tags, the name struct, and you can just use the name like this. Okay? 3 different ways to define. Now we can initialize struct variables with initialization list. So first is provide an initialization list with the variable declaration. It works just like array declaration. it provides, you can provide a partial initialization also with the variable declaration. From top to bottom, if you define value of 1 or 2, the lagging ones are set to some fundamental values. It works just like partial array initialization. We are showing the example here. Okay, here, this is the struct, type def struct sample. Okay, so forget about type def, I did struct sample. Okay, if you do type def, then sample will go here, which is missing here. Okay, and then if I say sample sam, there's x, y, t, and u, int, float, and character. Then if I put 2 here, that will be value of x. If I put 5 here, that will be value of y, right there. If I put 3.2 here, that will be value of t. And if I put a here, that will be value of u. This is the full initialization. But I could do partial initialization. If I do this sample sam2, 7 and 3, it'll initialize x and y, x to 7, y to 3, and put 0.0 for the float t, and for char, it'll put the null terminator value. Okay, that's the full and partial initialization of a struct. Okay, we'll talk about some aggregate operation on the struct. Aggregate operation is an operation on a data structure as a whole, as opposed to operation on individual component of the data structure. So what are the aggregate operations on struct that are allowed or not allowed? Input, output, arithmetic, and comparison of entire struct variable is not allowed. Okay. Input, output of atomic variables is allowed, but not of struct. Comparison of two variables of same type, like to int, using 6 relational operators allowed, but not for the struct, not allowed. These are the operations that are valid on the struct type variable, aggregate operation. You can assign two variables of struct of same type to each other, and you can pass them to a function by argument, and you can also return pass function as an argument, pass to a function as an argument by value or by pointer, or also you can return them as value from a function. Okay, now we're just going to show one more example of assigning struct, and then it will be best if we did some work on the compiler to show you some of these things. So if I declare two structures, x, y, t, and u as members, sam1 and sam2. So before assignments, sam had these values 2, 5, 3.2, and a. sam2 had these values 7, 3, 0.0, and r. And then I say make sam2 exactly as sam1. Then what computer will do after this assignment, they'll be identical. So all the values here, so value of u will be replaced by this one, value of t will be replaced by 3.2, value of y will be replaced by 5, value of x will be replaced by 2, and 2 will be identical. So this aggregate operation in struct, placing one struct equal to other, allows member by member copy from the destination to the source. that is allowed. Okay. All right. So I'm going to get out of the PowerPoint now and show you in Xcode some of those things. And unfortunately, I'm not going to use either sample struct or animal type because this one here is kind of meaningless, and the other one is too big. So I'm just going to use a struct student and show you different things in there. Close this one. Okay, I have to create a new project. Next. I might already have it one available somewhere, but since I'm already on the video, I should just do it. Bear with me. Okay, we're going to define a struct student, and I'm going to use the tagged one, and Xcode doesn't put a semicolon, so I have to be careful. Put that myself, and I'll choose char name. That's a 30. Int age, double GPA. This does not allocate memory, but I could do this. I could declare a struct student stdnt1. I could give them values John Doe, comma. Am I doing right, or no? Actually, it has to be on the right hand side, so it has to be this way. And then next was age, so age is, let's say, 20, GPA 3.4. This is the full initialization, and we can see that this works because I can print each individual member by dot notation access. So I can do this, printf student name %s / n close, and I can do stdnt1 dot name. Okay, so let's just run this much and see if we are getting the correct behavior. It's a little slow, but it works. See? So student name John Doe we initialized here in the initialization list, and so this was the write access, this is the read access, and we got it. And we can do the same thing with the age and GPA. Okay, %d for that, and I want to say word years after that, so I can do that here and close stdnt1 dot member selection of the age. So that's the dot notation member selection. Selection of the name field, name member, variable name dot age. Here's the age member selection, and then we can do the same thing for the GPA. GPA, that's actually in floating point, and I don't want to print more than 2 decimal points, so point to LF. Years is not there. And this dot I don't want because I'm printing a floating point number. And I do the member selection of the variable dot GPA. Okay, now it's going to print all those 3 values. John Doe, 20 years of age, GPA 3.4. Now I want to show the aggregate operation of using the equal sign. So now I'm going to create another student, struct student stdnt2, and I'm not going to put anything in there. So if not, I'm not going to put anything in there, it'll be just undefined values. But I'm going to do this thing. I'm going to do stdnt2 aggregate operation of assignment equals this. So if I print stdnt2, its components, they should give me the same value as here. Notice here stdnt2 had nothing. So I'm just going to change to 2, right? Now accessing the members of the stdnt2. Printf printing struct variable stdnt2 after operation 2 equal to 1. After that operation, okay? So you should get 2 prints exactly same. And we do, see? We do. Okay, I think it's time to stop. In this video we have done definition of struct, 3 different ways to define them. The tagged, type def or single variable. Fact that structs have members like arrays do, but they are heterogeneous. They could be heterogeneous. The structs keep related information together. Aggregate operation on the struct is you can assign one struct equal to another one. So there is member-wise copy from destination to the source. Struct can be passed by value or ref by pointer. We have not talked about pointer that much. To the functions, and they can be returned as return value from the functions. And we showed you the initialization list, full initialization list. I didn't show the partial. If you do partial, that'll work too. And you could have direct assignment also to the struct members. Maybe I should do that too. So if I come here and I say stdnt1 dot name, actually I'll have to do star copy. For that I'll have to include number include string. In that case, I can do this struct copy that into the name member or name field, put Lisa Adams, and then just reprint this part only. And you'll see instead of John Doe, Lisa Adams will be the last output statement. So I do have an error here. Oh, lowercase. No, it should be uppercase. Sorry about that. Yeah, that's definitely a compile error. And yeah, this is correct here. So last output should be Lisa Adams. There you go. It's been named Lisa Adams. That's example of write access to struct members randomly. You don't have to do that in any order. Aggregate operation. Printing each struct member separately because there is no aggregate way to print them using printf. Okay. So I'm gonna stop that video here. Thanks for watching, and we'll see you in the next video.